So I figured I would show you uh, how to get started with the Simplify3D with a blank project. Uh, Show you how to import some files into it um, and change your process, which is basically your profile for that printer and filament and or for the job. Um, and although you've already done this, just I figure I'll show you just in case that there might be something that I can better explain, or you can see me do like, oh, okay, that makes more sense. So starting with the empty one, I'm gonna head over to import. I just happen to have the guide here in my folders. Of course, it drops it in there just right. I'm using the right mouse button to move it around in space. If I wanted to spin it around, I'm using the left button, click and hold right, click and hold left, and zoom with the mouse wheel. So right now I'm looking at this file. I'm like, okay, this is not bad. It's on the table. It's flat. It is in the orientation that I want to print in. That's clearly not always the case, but for right now, let's go with that. So that's where it is. It shows the correct orientation on the print bed. Now I want to add a process. Say I want to print this and say pet G. So I'm going to add a process, and don't worry about the name up here for right now. Yours should look something similar to this. Probably process 1, and if you're still using the one I gave you, it'd be like nylon. Now I have a few other ones on here as well. As I was testing out different processes for both of my printer types, most of these up top are actually the MakerBot replicator, and then I think all the way from this one all the way down are for the D6 or the Ultimate. So I have a few filaments already created. So for Pet G, went here and check this out. So I selected that. Right now my infill density is at 11%. Say let's make that say 25%. Primary extruder is set to 0.4 and 0.4 manual. That's with a multiplier 1. That means that the nozzle is 0.4 and we're trying to extrude 0.4 of material. And right now I keep it manual. You can always play around with this to see if the printer can produce some better results. Right now manual is fine. Retraction is some more advanced technique. For Pet G, yeah, you want to have that on, and these settings, the following settings are fine. Basic retraction is whenever the nozzle moves to go to someplace else, and it wants to do that without letting filament ooze out the nozzle. While it do make that move, it basically pulls some of the filament up really fast, and it makes a movement and then continues to print. If you don't have retraction on, it can lead to stringing and artifacts on the material. Some materials you have to turn it off because it causes jamming. But for Pet G, it's totally fine. Same thing with coast at end and white nozzle. Those are things that help improve print quality. Layer is the next setting. This is your layer height. 0.3 is pretty coarse. For this printer with the 0.04 nozzle, you'll want to look at maybe a maximum of 0.1 layer height, 0.1 millimeter layer height. With a smaller nozzle and slower speed, you can achieve even higher resolution by going smaller, but with the nozzle you have right now, the lowest I would go is 1 or 0.15. So usually I print with something like a 0.2. So that's pretty fine. This is how many top solid layers and bottom solid layers. The more you have this, the more solid that your surface will feel for the roof and the floor. And as we discussed it today, the outline shells is how many perimeter shells it makes inside the part for the walls. And of course, the more you have there, can add rigidity. For my first layer, I usually like to have the first layer is 100% height, but like to fatten it out a little bit for the width and drop the speed down for that first layer. That's going to help you ensure that your first layer adhesion is pretty good. Additions is also what we talked about earlier today. Here's those 4 sections I was discussing. So whether or not you want a skirt slash brim, which would be that outline that goes around the part that doesn't touch the part. And that's with this printer, that's all I use. On my MakerBot, actually, I don't use these too often. I use a RAF. RAF is a lot more material heavy, like I said before, but it has some great benefits for when you want to have a problem with bed adhesion and stuff like that. Yeah, but it can increase your time. Depending on the part, it may not increase your time any noticeable amount, but it's worth the note. Prime pillar, that's for when you have like dual nozzles and you want to ensure you can always have the other nozzle primed. And effectively, the printer will just print a tower as it's printing your real part to keep the other nozzle primed. Don't worry about that. You don't need to worry about that. That's all. Same thing with ooze shield, because usually, I mean, these two things, it's a dual extruder primary focus. You can totally use this, and there's some other cases for this as well, but that's not for now. Infill, I usually keep using this particular pattern inside, and you can try different patterns. Some patterns are stronger than others. Some patterns take longer to print. Some are faster, so you can play around. I mean, just starting out, those stock are fine. That is the same number that's mirrored there. And basically I have it so here is every 10 layers is going to actually do a solid level. So it's going to do the pattern for 10 layers, and on the 10th layer it's going to then print a solid layer like a roof. And then from that point it's going to do the same thing. It's going to build empty for another 10 layers, and it's going to build a solid roof. And this is for the support here. I'm sorry, the infill angles, because like that pattern, makes like a cross, pattern, and that just says at what angle do you want to have the pattern. 45 is, and that's fine. Support, this is very dependent on what you're printing. Some things you want to use support, some don't. For this particular part, there's no reason to use support. There's no overhangs whatsoever. Even if you click this, it's not going to generate supports. So that's why this is off. Otherwise, you can just click the button and it will automatically generate supports for you. You can also manually go in there and generate supports. That's a bit advanced, okay? And I'm just now getting to that myself. But it's not hard. It's just one of the things. If you're doing this, you have a good reason to. Support, but in support in general, yeah, use support whenever you need to. It's good. That's why we have it. For temperatures. So for Pat G, yeah, that, like you said, that is freaking high. I usually is around 240 or so, depending on what brand I'm using. I have a couple brands that I have in-house, to include the Amazon one, which I'm using right now. Sane Smart, Hatchbox, and I don't think I have any MakerBot stuff left. So you gotta play with the temperatures here. Some temperatures, some for different filament brands, they use slightly different blends, and thus you might want to try different temperatures. They make those print towers I told you about before, where people print the part, and you can print it and set it at different temperatures and see at what point does it no longer look right, or at what point does it look best. And you can set a range of temperatures. It's actually in here pretty easy. So for the primary extruder, right now I only have one print temperature, and it starts at layer 1, and because there's no other instructions, it keeps it the same the entire time. But say I wanted to have it so that at layer 10, change it down to 200. Well, it's that simple. I just added a set point. Actually, I just added a set point, just like I'm doing now, and say at layer 90, I want you to change it to 300, right? That's crazy, but you can do that. I didn't want to do that, but anyway, yeah. So as you can see, you could just keep stacking and adding different temperatures. which gives you a lot of flexibility that otherwise you don't have. So, but one temperature for the first layer, and that'll keep it stable. For heated bed, exact same principle. Now for PETG, about 70 is pretty fine, especially since mine's in the garage. So the temperature can be a little colder and a little draftier. And PETG is more susceptible to that kind of bed warping, which is why you want the heated bed, than say PLA is. So yeah, that's fine. Of course, you can definitely play with that. And like I said before, keep the print temperatures that you get from manufacturers. They are more. You can think of them more of as a reference, as a rule of, as a guide, because every printer is going to be a little different because of how they measure their nozzle temperature. So even if the printer tells you that, yeah, I'm at 270, at the nozzle, the filament actually may be at 280 or 250. So that's why it comes down to being individual printers versus what the filament tells you, which is usually why they give you a big range, like, from PLA for example, maybe anywhere from 190 to 210. Well, that depends on the printer, because I can tell you right now, the Replicator 5th Gen default for PLA is 215, which you may say that's pretty high. Well, for that printer, the way it reads, that's actually that's just the way it is. That way it reads. You try to print at 190, and you'll probably have a lot of problems. The stringiness, under extrusion, clogs, those kind of things. And it, once again, depends on the filament too. Some filaments, they like to be printed really low temperature. Some filaments, you try to push it out at 210, and it's gonna struggle. So that's just something you got to play with. Cooling. So this is that bottom fan, not the top fan. The top fan should always be running, and that you don't control that. The moment that thing starts heating up, that fan should be on. And sometimes you might have to tap it, especially if it's been sitting for a long time. Eventually, you should replace that fan because it's it's a cheap fan anyway. But this is for the bottom fan. This is only time you're really gonna be using this. And as you see here, mine for PETG is set to 0. Is because you're printing PLA or like TPU or some other low temperature filament. Otherwise, you're printing nylon, PETG, ABS especially, PC, you're not running this fan. You run this fan and you're going to run risk of having the part pull up from the bed and have a failure. But if you do want to change it, it's the exact same way as the other temperature stuff. You just set the layer you wanted to come on and set the particular fan speed as a percentage. It's that simple. But right now I have it set at 0. Here's a bunch of settings. I can go over all these right here. Just make sure your stuff looks like this on here. Down here is the actual global offsets. Here's the number I was talking about before as far as adjusting your bed height for each material. You want to dial that in a little bit. Now, I was playing with this earlier, but I think for PETG, I'm around, it depends on, I think I might move my bed, but it should be around, for me, 0.07. Ideally, for your printer, it should be 000, but you can, if you want to reduce the amount of squish your nozzle has on the bed, you can go in here. Positive number lifts it up, negative number brings it closer. So if you go to print and it's like, ooh, it's too close, you can always put a slightly higher number in here. So as you see there, I was running a 0.17 for polycarbonate, which is why that's there. And over here, these are the build volume dimensions for the printer, and this is when the slicer is making your actual file. I have it for update machine definition versus using the global one that's in my settings. That way, these settings here for the printer dimensions match the printer that I'm actually trying to print with, which in this case is the Ultimate. My MakerBot one, when I go to the profile, it has a different settings here that updates accordingly. So I don't have to open and close the program or change anything else anywhere else. I can literally, save the file for this particular print job, come back in here, change the profile to one of the MakerBot ones, and then hit print again, and it'll give me a file appropriate for that printer. You only got one printer, so it's not that big of a deal. But these are the settings for the Ultimate. So not checked there, and that's pretty much straightforward. For the scripts, there's a lot of cool stuff you can do here. These are what these are setting the instructions for the printer to do at these particular action points. So at the start of the print, these are some settings I got from I stole from somebody else. So basically, it has it so that it turns on, it turns off the fan, because I actually didn't want the fan to run if it was already running, and then rehome itself, lower the build plate, which actually it sounds confusing, but that really means raise the build plate to the nozzle. It means lower the build plate, bring the nozzle to the bed. Zero to extruder, that's more of a math thing, so the printer knows, okay, now that it's been zeroed to the bed, now record that as the new baseline. Then I added a 0.2 offset to the z-axis to bring the nozzle off the bed, 0.02 or 0.2. Do a purge, basically it runs a little bit of filament through the nozzle, and then do a wipe, which is effectively just run the nozzle across the bed as you saw it on yours, and then at the end of its run, start printing. The reason why you want to do that, you want to ensure that when you start printing that there's actually material that's been purged through the nozzle. And that's just a trick to get it to ensure that when it starts printing, there's actually material there. This is very similar to what the stock MakerBot does. If you want to do a layer change script, you can do stuff like this. So, and this is just G code, so you can have it so that it does, in the middle of a layer change, it does something weird. So you can have it so that it always put the nozzle back over home and then come back if you want to. You can have it so that whenever it's doing retraction, it's doing something special. Tool changes, when you have more than one head, you don't have more than one head, so don't worry about that. The end script, so the very important thing is too, when you're done printing, or then when this printer's done doing its job, what does it do? In this case, I have it home the nozzle, lower the build plate, bring the heater, turn off the heater, turn off the bed, and then disable the motors. So that way, this should present the part to you with everything off. If you don't set these and put these in here, the printer will kind of just stop, and wherever the nozzle is, it'll just stop. You don't want that. It's messy. It's not the way it should be. But in the firmware, in the stock firmware, it doesn't have any of these instructions, so it just does nothing. So yeah, that's what you want to add. And even in Cura, you want to ensure that you add these starting and ending scripts in Cura as well. For speeds, the printer can actually do pretty fast speeds. That's the stock speed that people run on these things, about 45. And for PAT-G, 45 is pretty fine. And these are adjustments, so when, the default speed is 45, but when you're doing particular parts like the outline, or you're doing a solid infill, you can say, okay, I only want you to run 50% the speed of that. And when you're doing a solid infill, I want you to run 80% the speed of that, and so on. Down here you have the Z movement speed, which is how fast it goes up and down. I think 20 is about the max you really should be running that thing. The max you can run from here is actually pretty high. I want to say it's like 150 millimeters per second, which is pretty fast. And that's the movement, the X and Y, when it's not actually printing. So when when it prints and it's like, oh, I gotta move to over here and finish. That's how fast it is. Now, if you set it too fast, without getting to the weeds, it can jerky and really fast. It would actually destroy the printer. But don't worry. I would say set this at maybe 120, 100. And that's plenty fast. So it just that much time it takes for it to move while it's not printing. And over here is adjusting. You got a speed override for, like, okay, when the printer is printing very low level layers, you can have it so that I want you to bring that speed down to 50%. You know, you can have it so that no, I want the slowest it can go down to is, you know, 80%, which means that if it even wants to do that, it doesn't matter, right? It will still go to this. But you really don't need to have this on, especially consider, I think, yep, over here I have it so that the first layer speed is 73%. But you do, I did this because I wanted to ensure that I had some more finite control over the speed. Speed is one of the things when you first starting out. Certain materials you want to go slow and then slowly and then crank it up, because some printers like to go fast on certain materials, some don't. Even though the printer may be able to move real quickly, being able to get the material through the nozzle and on the bed without, you know, being all mushed up or messed up or underextruded, that it matters. And not all printers can do it the same. But this printer is actually pretty good at that. Really nothing in here that you need to be worried about right now. We could definitely discuss these things later. We could definitely, we can discuss things. So for the most part, that's all set up. I'm going to go ahead and update profile because I made some changes. So for my PETG profile, that is now set up correctly. See here, yep, nothing changed there. So hit OK. So now it shows that process 1 is there, which is the one I just set up for the PETG. There's the part still there. Now I'm gonna prepare the print. And now it shows how it's gonna look when I go to print it. You know, you can adjust, you can go through the different layers and see what the printer is gonna be doing on each layer. And see those crosses? That's the actual infill. That's the infill. And let's see if I get a better shot of that. Where's my cursor? Okay, there you go. And see this blue line here and this blue line here. Those are those shells. So this is the 3 shells. So you have the outer shell, 2 inner shell, and then you have your infill. And as you can see here, you see that that's that 10th layer. That's that every 10 layers it does a solid layer, and it goes back to doing infill, and then another solid layer, and then infill, same on. Those are those are your brim. See I'm doing those brims there. It just shows you where the nozzle is at that point. Those little dots right there is actually when it does a retract. It shows you where the retract is. So so now that, yeah, I'm okay with that. I'm happy with that. I come over here to prepare the file. Now if I had a printer, I had to have that printer hooked up directly by USB, I could print straight from here, but I don't. So yep, that's the file that I'm going to make. I'm going to rename this PETG. Actually, name this mono price PETG. The reason why, because I have more than one printer, and I wanted to make sure that when I save the G code, I know what printer it goes to and to what filament. I have a folder. I'm saving this all to my OBJ folder. Okay, saved. Now I come over to, I'm currently running Retraction server for the printer instead of running the Pi. Like I said before, I'm going to swap back to the Pi, but it works pretty much the same way. It has a built-in slicer, which I don't have right now because I didn't pay for it, but same exact principle. Let me go ahead and change to my PETG group. So I have a couple of files that I already uploaded to the server. I'm going to upload the file that I just made. There it is. And it's uploading. And there it's done. So now this is actually on the server or the Nook that's in the other room, in the garage. So at this point I can print any one of these particular slice files that I already previously sliced, and or I could do a direct print. In this case, I'm not going to do that. but I am going to just say, for instance, if I want to print this, I would then come over here and I would press this button. I mean, maybe to back it up. So this is what this interface looks like. It shows IP address, stuff like that, where I can find this server, and then it shows, yep, there's the printer. Okay, there's the current job running. Yep, it shows my temperatures. So right now the nozzle shows 14C, bed is 12C, fan's not on. That's a flow rate and that's a speed. Just like in Octopi, you can come in here in real time and adjust these as the printer's going. Before the printer goes, you could do a preset. Say, hey, all right, get ready to print some PET G, which I have in here set for 220, and it'll get that bed going. I'm like, yeah, get the bed set at my preset. So right now it's warming up the bed. I'm turning it off. So right now it's warming the nozzle to my desired temperature of 220, and of course you can adjust that at will. I could wait till that stabilizes and get to where I want, and then hit print. If say I knew I was going to print something, I might come in here and preset this, so that's warming up while I'm in here getting ready to slice stuff. And that way, by the time I'm done slicing this and get the file ready, it's already warmed up. But you don't have to do that, as you know. So then I'm ready to print this particular file up here, I would then just hit this button, and boom. Now the printer profile is going to take over and get the nozzle and the bed to the temperature that I want. And once it gets those temperatures, then it'll just print it. And it'll give me some status updates up here. How long I think it'll take in previous jobs. So this is from the basics of getting a file imported in to S3D, making sure that you add a process appropriate for your part, your printer, and your filament desired. Ensuring you prepare it, you inspect it, make sure that it's what you like. You save it to some place you want to save it to, which you also could include, SD card for direct print to the SD card, and then go to your web interface of choice and upload the file and print. That in this case, we're not using the slicer on the server. We're using the local slicer. Gives you a lot more control, a lot more graphic horsepower, the really model stuff. Because sometimes stuff is really complex. You try to do that on a low power machine, you're gonna be frustrated. So all that in a nutshell. That's I guess a nut to soup way of printing stuff from the monoprice.